Now? Yes, you can. Awesome. So, good morning, everyone. How are you doing?
We're fine.
Okay, see ya. Thank you. Okay, cool. So, we're going to start with this. Who knows what this is? Fresh body, fit mind.
Not developer.
Not developer. True that. So, fresh body means, you should be active in order for your mind to be fit. So, in light of this, please all stand up.
Yay!
Yep, it's happening.
Don't walk out the door, though.
Yeah, don't lock the door. Okay, so you're all standing up. I'll tell you, very simple exercise. Here's what you need to do. I'm sorry for showing my back, by the way. So you need to raise up your arm like that so that your elbows are at the level of your eyes. I'm watching, okay? And now, clap your hands. You may sit down, and I have this slide because some people are still standing like, what? And then, oh. So, thank you for the standing ovation. So what I do, I collect these pictures, send it to my boss, and I'm like, show me the money. Anyway, okay, so on a more serious note. So today, I'm here to tell you a story. I'm here to tell you a very, very visual story. Okay, so the one thing that I want you to know about me is that I love watches. Okay, I love quartz, automatic, manual, doesn't matter. I really like watches. So the other day, I thought I'm going to visit this. We shall not name which company's websites. I tried to do my best to sort of blur out the name of this company. And what you will see on this recording is my connection speed, the network requests, and then the experience, right? So imagine that I'm like, I just really want to buy a watch. I mean, I have a watch, but I wanted to get a better watch. And I thought, I really want to buy one of these. Like, I want to just, it must be so beautiful, right? I mean, you can already see the strap. The dial must be amazing. Oh, okay, so now I can pick one. So let's pick, I like that one. Okay, so we arrived. Okay, so I do some additional things, but just to make things faster, this is or was one of the problems, right? So you see what's wrong here. If you don't see what's wrong here, then you're in the wrong room. but what's wrong here, right? So they have these little containers of 300 pixels, the image is 3000 pixels, and it's 1.5 megabytes, and they try to load into that space. So that's not good, right? No matter how fast your internet speed is, as you saw, it's just not a good experience for your users. And so what I'm going to say is, today we live in the world of the visual web, right? Every website that you visit is going to have some sort of an imagery. These days, there are lots of videos that you see, right? So in fact, I'm going to go as far as stating that we are no longer working with, hypertext, but much rather hypermedia, right? So it's just basically images and videos everywhere on the web. Now, in the past 2 years, I was involved in the Almanac Project, the Web Almanac Project. I don't know if you've heard of it. It's basically a report created by Google on every year on the current state of the web. So they have a large database of I don't know how many millions of websites, and then there's chapters for each of the various topics. So there's a chapter for HTML, for JavaScript, for front-end frameworks, and there's also a media chapter. And then there are two findings that I'm going to share with you today. One is that 95.9% of all the websites that were part of that, overall report contained at least one meaningful image element. Meaningful image element being like a picture or something that is visually trying to represent something. So that's pretty much, nearly all the websites. But then to take that a step further, 99.9% of all those pages or all these websites made at least one request for an image, which means we have images everywhere. So this was, I don't know if you know this, but this was apparently the first photo on the web. So that's 1992. So we went from that to last year, where at the 90th percentile on desktop, you have 70 images. That's 70 images on a page. That's a lot. So what does this mean for developers? Well, what it means is that you have to kind of figure out a way to work with images, right? Especially in modern UX design, if you think about it, you visit a website, normally you have a hero image of some sort, right? Or maybe a hero video or a video in the background. So every time when you visit such site, you know, well, that's a large portion of that. Now, Google has also done some amazing things for us in terms of trying to, well, they've done it for the users, not for the developers, but never mind. So who here heard of Core Web Vitals? Most of you, okay. So Core Web Vitals, there are 3 metrics that Google basically created and announced that helps with the usability, the interactivity, and the speed of websites from the end user's perspective, right? So what that means for developers is that there are now 3 metrics that we need to adhere to so that we make sure that we fall within the boundaries that Google have specified in order to provide a great experience for the end users. Now, one of those metrics is called the largest contentful paint, or LCP for short. The idea of the largest contentful paint is that Google is going to measure how long the largest element it took for the page to load, right? The largest contentful element can be an image, or it can be text. It really doesn't matter, but as I said, most of the time in modern UX design practices, it is going to be an image. Okay, and that's the sort of criteria that you have. Whatever the largest element is on your page should load between 0 and 2.5 seconds. If you do that, then you're in the green. That's a good experience. 2.5 to 4 seconds, still okay, not the best, but you know you should work on it. 4 seconds and above, okay, that's just poor. The other important thing to note is that the results from these 3 metrics, so there's first input delay, which measures these kind of like the interactivity, cumulative layout shift, which measures how long the page elements are jumping, and then LCP is the 3rd one. All of these are also taken consideration into determining the search page ranking. Okay, so if you have bad scores for any of these, then your site is going to be demoted, I guess, in the search page ranking. So our goal is to try to load the resource as fast as possible. Now, I'm going to show you this rule, which is the 40-10-40-10 rule. Most of the time, this is applicable to images, so when the LCP is an actual image. So what is this 40-10-40-10 rule? Anyone knows, heard of it? Okay. So LCP itself, as a thing, consists of these 4 items. Changing any of these 4 items or reducing the time for any of these 4 items will ultimately result in you getting a much better LCP score. And the idea is that you take time to first byte, you try to reduce that at around 40%, resource load delay around 10%, resource load time 40%, and element render delay 10%. And if you do all of that, you spend a lot of effort on that, then your overall LCP score is going to be a lot better. So what are these 4 elements that make up the LCP? The first one is time to first byte. So time to first byte is basically the time that is measured from when a request is made for a resource and then receiving the first byte of that resource. Okay? So one of your goals is to try to reduce this TTFB, or time to first byte. The question is, how do you do that? Now, allegedly as developers, this is the one item where we don't have a lot of control over, because these are things like, you know, try to reduce how many redirects you do, or try to use HTTP2 or HTTP3. Now, some of you may be in a situation where you can actually control some of that, but most of the time it's outside our control. You can use things like predictive prefetching. I don't know how many of you heard of Guess.js, which is a very interesting library. Basically, it takes Google Analytics data, feeds it into a sort of AI machine learning model so that the Guess.js will try to automatically predict, based on the Google Analytics data, what is the next page where the user is going to go, and it starts to sort of prefetch the data for that site automatically. The other thing that I'm going to say is, you know, there's a lot of discussion these days with the Jamstack and then pre-rendering and static site rendering and so on and so forth. For you to reduce the time to first byte, you need to, or you should be using pre-rendering as opposed to server-side rendering, right? Because if you ask for a site to be returned by the server and the server needs to generate that HTML, that generation is going to just prolong your time to first byte because it's doing the job, right? Whereas if you have something pre-rendered, meaning that your static HTML files are in place, you make the request, the server just sends it back. It doesn't have to, build anything. So that's one, right? So you did that, great. Then we have the resource load delay, right? So the resource load delay is a delta between the time to first byte and the browser starting to load your LCP resource. Okay, and your goal is to try to eliminate or shorten this resource load delay. So the question is, how can you do that? Again, a very general rule of thumb is that the loading of the element that is considered to be the LCP element should start at the same time when you load the first resource. So let's say you load a CSS file or JavaScript file. At that point, you should also start to load the image or whatever is going to be considered to be your LCP element. Now, what happens with browsers is that they do, the browsers have this preload scanner, right? So the browser is going to take a look at your HTML and then automatically attach priorities to the various items that you are requesting, right? So it's going to say, oh, there's a font, there's an image, there's a CSS file, and it's going to say, the CSS should have a high priority, the JavaScript should have a medium priority, so on and so forth. And it does that automatically. But a new feature has landed in Chrome quite recently, which is this fetch priority hint, which means that you can add that to your elements and you can kind of poke the browser and say, well, I need you to treat that element with high priority. And then it's going to, start loading that resource as soon as possible. Then we have, this is the third one, the resource load time. Very simple. How long, how much time or how much it takes for the LCP element to load. Okay, and again, your goal is to try to reduce this load time. So how can you do that? Well, if you think about it, especially with images, the smaller that image is, the less time it's going to take for the browser to load that, right? So trying to reduce the amount of bytes that you're transferring through your network, okay? So it means you should have highly optimized images because, smaller image sizes will mean that they will come through the wire much faster. The one thing that I will also say here is, providing the fact that your LCP element is say a paragraph, and if you're using some fancy fonts to display that paragraph, the LCP calculation will also take into account the time it takes for your application to load the font. Okay, so then as opposed to trying to add the fetch priorities and whatever to the image, you need to also think about the font and how you get the font face. Okay, because as I said, it could potentially make that LCP score higher because the browser is waiting for the font to arrive. And then, last but not least, element render delay, which is the delta between the LTP resource being loaded, so the bytes arriving through the network, and then whatever that element is to be fully rendered in the browser. Okay, so that's the element render delay. Again, you need to make sure that you sort of shorten that time that it takes for the browser to do this job. And there are a bunch of things, and I'm pretty sure that if you work with the web, that some of these, inlining your CSS, resizing your bundle sizes, deferring non-critical CSS and JavaScript. These are the standard things. One very important point, and this is very interesting because a lot of time you hear that you should lazy load your images, lazy load that. If your LCP is an image, then don't lazy load it because, right? Like, that doesn't make sense. A lot of people are like, oh, but I was told I should lazy load everything. Well, yes, except the LCP stuff because you want that to arrive as fast as possible to get a good score. Now, if you sort of lazy load that, God knows when it's going to arrive, right? So just don't do that. Okay, so next I want to talk about my favorite topic, which is image formats on the web. Because again, remember, let's assume that we have an image that's the largest component. We start to fix some of these things that matter for LCP, and then we arrive to the point where we have one of these image formats, right? JPEG, WebP, whatever. Now, just to let you know, again, this is from the Almanac report from last year. JPEG has been and still today dominates the web, right? That's the most popular image format on the web, followed by PNG, GIF, WebP, and SVG, and you know the rest. And obviously, hopefully the reports this year will start to show AVIF in that as well, because that wasn't a very widely used format last year. But then when I say JPEG, which JPEG do I mean? There's baseline JPEG, there's progressive JPEG, it has lossy compression, however JPEG 2000 can be lossless. So there's lots of variations of the JPEG image format as such. And I just prepared a quick video, so what you will see here is the way a baseline JPEG is loading and the way a progressive JPEG is loading. So what I've done, I throttled the network very heavily. So what you will see in the baseline JPEG, it will load sort of line by line. But what gets loaded is already the high quality final version of the image. Then straight after that, we're going to load another JPEG, which is going to be the progressive one. So you will see that the first image that arrives in a second is going to be blurry, but then you will see that there's another iteration. So you see it's blurry, but then at some point in time, it becomes clear, right? So it loads progressively. So the benefit of this is your users will see something that they know, kind of can figure out what's there, and then behind the scenes, the browser will load it. What matters is that for the LCP, it doesn't matter, because LCP will measure when the entire image has arrived. PNG, some of you may use PNG. PNG is by default lossless, but for whatever unknown reason, every time when you save a PNG using one of these popular tools, like Photoshop and whatnot, they will produce a lossy PNG. Whatever, okay? But generally speaking, a PNG image would be larger compared to a JPEG, but there are some edge cases when that's not true, but just FYI. Then, GIF, GIF, doesn't matter. Don't use that, thank you. Unless you do that, and I'm not going to tell you what that is, that's your homework, okay? So you can take a picture of that, you can figure out what it is, but really, why would you ever want to use a GIF on a website? Just for animation, okay? I've seen a website where someone used a GIF as a video, and it was 16.8 megabytes. And it was 6 seconds. Why? Okay? But I'm nice, so if you really want to do that, do use that. Okay? So if you really want to get funny animations, use the video element, generate an MP4, add muted autoplayed loop attributes, and it will act like a GIF. But it's going to be a fraction of the size. Okay? So that's your solution right there. Okay, so we have WebP. So WebP is considered to be one of the next-gen image formats. So if you maybe seen a Lighthouse report, you get the use next-gen image formats. That's WebP. WebP is good. It was derived from one of the video codecs and all the video formats. It supports lossless and lossy, and very generally speaking, it's about 25. It's between 25 to 35% lighter than any JPEG would be, and it still provides the same visual quality. Okay. But do check browser support. Older versions of Safari do not support WebP, for example. And also FYI, WebP 2 is currently being worked on by Google. Then we have AVIF, which is another image format that got derived from a video codec. It's great for lossy and low fidelity compression images. So you can get very sort of high quality images, but at a fraction of the size, again, if compared with JPEGs. It doesn't support progressive loading, which is very... why are you doing that? What? Show me again. GIF, the G is soft. We're at a conference. I'm not going to say what else is soft, okay? Okay, so... I have no idea what I was talking about now, because I'm thinking about the soft G. Is GIF, G, it doesn't, Jesus Christ, sit in the back. No progressive loading. No progressive loading, yes. What that means is that even though an AVIF image is going to load fast, you're not going to see anything. It's just going to be a blank space. And the other thing is that you have to be aware of is the encoding and decoding time, especially if your image is very, very large. Then it takes a lot of time for and if this is you're running something in your CLI or using a tool, if you take a lot of time to generate an AVIF. And then we have my favorite, Jpeg Excel. Who heard about Jpeg Excel? You're my man. One person. There's always like one person in the room. So Jpeg Excel is the latest version and iteration of the JPEG standard, and it's available in the latest version of Chrome behind the flag. So you have to go into settings and enable the Jpeg Excel flag. Very simply put, it's a renewed version of the original JPEG spec, okay? But taking all the great stuff from WebP and AVIF and others into consideration. So this image format is going to be really big. Not now, but maybe in 2-3 years' time, you will hear a lot more about this. I know you can't read this, but there's a link which you can get this from. So there's a battle of codecs, which basically using a few pieces of criteria, comparing JPEG, JPEG 2000, PNG, WebP, AVIF, and Jpeg Excel, where you see all those yellow and blue dots, that it can do everything. That's Jpeg Excel. Okay, so it's going to be a very important image format, hopefully very soon. So here's another video for you. So what I've done, I built this very great looking tool using all my CSS skills, where I have I allow you to select image formats, and then what I do behind the scenes, I take one image, I split it into 3 parts, and then I load the individual parts as based on your selection. So this time around, we will get a WebP, an AVIF, and then a progressive JPEG. And you will see that even though the AVIF is going to load first, it's going to be just this blank space in the middle, okay? So we kind of see what the other image formats are doing, and then the AVIF loads, and then the rest of the image formats also finish loading, okay? So just be aware of this and make sure that you know how these image formats are going to behave so that you can present this to your users. It may be that your users don't care to, stare at the blank space for a second or two, but, you may want to consider progressive JPEG. Let me just reiterate the fact that LCP it doesn't matter if it's progressive or not, it will always measure the entire load time for the image itself. So what can you do? You can use this differential loading technique. This is fairly common. So you have the picture element, which can have a bunch of source elements, where you have like a WebP, a JPEG, and then a fallback image element. This is good for situations where you want to support multiple browsers, right? And you have a WebP format or WebP image for situations where people visit your site that actually support WebP. Okay, so the browser will read this line by line, and if it can render the WebP, it will never go to the second source element. Okay, but if it doesn't, it will go to the second source element, and then it will of course read the JPEG file. You could provide it an AVIF or many others. Or another option is of course to use an image CDN. So in the next sample, we have the same image. Who knows who this guy is? This is the second conference and no one knows who it is. This is very, I need to change this. Yes, thank you. J Balvin, it's a singer, doesn't matter. So we have the same image, right? You look at it and you think, okay, that's exactly the same, except one image is 200 and something, the other one is 100 and something kilobytes in size. So what is going on here? Well, let's take another test. There's a tool called Simulacra, which is it's a C++ project. I did bring it to WebAssembly as well a couple of years ago, but basically what it does, it compares two images, and the way the Simulacra project was built is that it's not only looking at the image data, but it also feeds information, or it also uses information that was done based on user research. So we actually, and this is a Cloud project from probably 7 years ago, we showed two images to people and we said, do you see the difference? Yes, no. And we marked the result. We did the same for other images, right? So basically this tool can determine if two images are really different in terms of their visual quality or not. And so it gives you a number. So if the number is anything above 0.1, it means that there's going to be likely visual deficiencies with the image, like pixelation, or it's just going to look bad. Anything that's below 0.01 is going to mean you can't tell the difference. So I ran these two images through that tool, and I got 0.0063, so that's good. Now, the only difference between these two images is the fact that I changed the access URL for, this is a Cloud URL, which acts as an image seeder in our case. I just added Photo and Qauto to the second image. Photo is automatic format, Qauto is automatic quality, right? So with those two flags, I was able to generate an image, because I opened this in Chrome, it gave me a WebP, and the Qauto flag automatically reduces the quality of the image in a way that is not visible to the human eye, which we also verified using that Simulacra tool. And the end result is that one image is 200 and something kilobytes, the other one is just pretty much half of that, okay? So there are, obviously, I do work for Cloud, so that's the only thing that you should use, but there are many other such providers out there, so feel free to do your research. But what I'm going to say is that don't do what that watch website did. Don't try to load 1.5 megabyte images. Try to shrink the images, and if you use the right tool, Cloudinary being one of them, and many others, you can also change the width of the image right in the URL, right? So W_1200 means that I'm generating the 1200 width pixel image just by changing the URL. And of course, we have support for JavaScript as the various JavaScript frameworks, YSDKs, so you can do this programmatically as well, and a lot more. So, some additional quick tips. The first one is a very important one because I did that many times. So you can measure LCP using DevTools in Chrome today. So there's actually an overlay, but you can also use the performance and the new Performance Insights panel in DevTools to measure how long the LCP element takes to load, and also what is the LCP element in your code. But make sure that you pop out the DevTools, because if you just open the DevTools, like on the bottom of your browser, LCP is going to be, the LCP is going to be calculated based on the element that is visible in the viewport. So many times what happened, I opened DevTools, I got now, obstructed half of my websites, and then it said, oh, your LCP is an H1 element. And I thought, I'm sure I have a very big image there. What's happening? So just make sure you pop that out, and then you take a look at the entire viewport. Lazy load an LCP element. I said that, and also for development purposes, it's good to use DevTools because it will show you, inside Lighthouse, you get all the performance reports. It will also give you LCP scores and other core Web Vital scores. But you should also use PageSpeed Insights, which uses real user data. So it's going to take data from people who visit your site and measure that, right? And that's how you should collect the LCP data, not from your sort of like synthetic lab environment. That's good for getting started, but you want to make sure that you collect real user data using PageSpeed Insights, and then you determine your LCP score using that. Okay, I'll leave you with a few links here. You can take a look at those, and that was me. Thank you very much.